Alright, so for question number 3 here, exercise number 3 here, it's asking us to write a non-fruitful function, which if you remember is a function that does not return a value, called drawPoly, which will take the arguments t, sides, and side length, which makes a turtle draw a regular polygon. So when you call it with drawPoly, parentheses test, 8, 50, it should draw a shape like this, which is using turtle test to draw an 8-sided shape with shape line side lengths of 50. So let's go ahead and start by just writing out that exact function definition. So there we go. So use turtle t to draw polygon of sides with length of side. There we go. You can't read all of that, but believe me, that's what that says all the way out there. Okay, so that's our doc string. So let's think about what we need to do to make this happen. While I'm at it, I'm just going to import turtle at the top here. So if I wanted to draw a square, what would I need to do? Well, I would need to have it go forward size, which would, in this case, side length 50, and I would have to have it turn left 4 times. So if I was going to use drawPoly to draw a square, I would do t forward side length, and then t left 90, right? But that doesn't work, and then I would need to do that for I in range 4. Okay, so this is right here our draw square function. And we can take that and generalize it to make a draw polygon function the same way. So how do we get to this 90 when we did the original draw square? Well, the answer is that there are 360 degrees inside of a regular polygon. And so if we divide it by that length, or by 4, we get 90 for how far we need to turn our turtle in order to get a regular polygon. In this case, a square. So 4 sides to a square, 360 divided by 4 equals 90. So if I wanted to generalize that, I would have it turn left 360 divided by the number of sides. And in the case of the square, that would be 360 divided by 4, which would be 90. I would also need to replace the range up here 4 with the number of sides, because as we said before, we want it to repeat as many times as it has sides. So if it has 4 sides, it'll repeat to draw a square of 4. So for I in range sides, move forward side length, and turn left 360 divided by the number of sides. Now truly, this should be it. This should be all this function requires. So let's set up our turtle and see if that works. So wn equals turtle dot screen, and let's set the background color, which I believe is this. We'll set it to light green to match what we've been using before, and then let's create a turtle. Let's use Alex again. Alex equals turtle dot turtle, and we'll set Alex's color to hot pink to match what they've used, and we'll set Alex's pen size to 3 to match also what they've been using. And I notice as I do this that I should be putting this inside of a main function, so let's do that. Let's define main and put all that inside the main function. Very good. Alright, so if we want Alex to draw a square, we would need to call draw poly Alex for t, sides would be 4, and side length, let's just do 20. And then at the bottom, we need to, when exit click is, I believe, the correct version of that. Whoops, and I've done something wrong. I did not call main. So remember that if you want main to run, you need to call it like this, or to include the if underscore underscore name underscore underscore equals main, the way that we've done it up here. And we'll use that for programs that we write when we start writing actual programs and saving them and running them from the command line. All right, so let's give this a shot here, see what happens. So that works. He drew a square. Now let's change that. Let's give him 5, see if he draws a pentagon. Perfect. Let's give him 10. See if that works. Perfect. Now as this gets larger, it'll get closer and closer to 0, right? Or closer and closer to a circle, rather. So if we keep making this bigger, it'll get more and more circular as time goes on. Perfect. But it should work now for any regular polygon. So run it with 3, we'll get a triangle. If I run it with 2, obviously, it's not going to function correctly. It'll just give us a straight line. And then we can also mess with the side if we want to get an equilateral triangle, a regular triangle with sides of 40. There we go. We can do even things weird like 7 and make a septagon. It should work. So there we go, a generalized function that will draw a polygon, and it's really as easy as changing a little bit of that function that we used earlier to draw a square, just changing it slightly and generalizing it even more by thinking kind of geometrically and computationally about it.